Hello everybody, a little bit of chaos in the background here, which is why I'm slightly late. And he's off. Well, I was going to say hello from Grigri's disappeared. Well, Grigri's keen to get going, so let's take a cue from him and let's get started with today's maths. So, today we're looking at word problems. Now, word problems, I mean, what are they? There's no real definition, it's just wordy maths questions. But people hate them. And today we're looking at sort of multi-step word problems where there's more than one stage. It can mean lots of kinds of questions, and well, let's just get cracking. Someone says, "No, I'm late." No, you're not. You're perfectly on time. Lilac X Mist loves Grigri. Fantastic. I'm sure Grigri's delighted. Oh, he's right by my feet. Let's see if he wants to come back up. No. Oh, he knows. He knew. He's fled. He's fled. No more Grigri. Maybe he'll come back later on, or maybe Dimitri will. You never know. Now he's climbing on the table. Yeah, crazy Grigri. Right, let's do a... Oh, hang on a sec, we've got a cat. Yes, we have him. Hello, Grigri. Come on, say hello to your fans. Say hello to your fans. Abdullah says, where is the worksheet? Grigri, stop it. Stop it. Come on, just stay behind. Just stay here and say hello to everybody. The worksheet is linked in the video description, which is down there. So it's underneath on YouTube. It's above. No, he's off again. It's above on Facebook. You can click it and download it. If you're on my mailing list... you get the worksheet in advance, a few days in advance normally. When I'm organised, you get it on Saturday morning, and then you've got a few days to do it before the lesson. If you want to get on my mailing list, sign up for the free papers on the OSL Educational website, and then you'll be on the mailing list, and then you'll get the worksheets every week. Magic. Let's get started. Right, so these are pretty horrible questions, but you're super smart, so you'll be fine. And look, if these are puzzling, don't worry about it. These are the kind of hard questions that come late in an exam. You're learning. If they're difficult, that's fine. Just try and work out why they're difficult, practice the skills, and in time, they won't be so hard. It's just about being systematic in how you present the issues. So, a large sack holds 20% more potatoes than a small sack. If one large sack and one small sack together contain 77 potatoes, how many potatoes does each sack hold? So let's just visualize this a bit. And by the way, I'll tell you now, there are several ways of solving this. I'm going to show you two ways of solving it. So you've got some options. Right. So we've got a small sack, we've got a big sack, and together they hold 77 potatoes. And this plus 20%, that's an arrow, sorry, plus 20% equals that. Okay, so that's the kind of situation. And they've each got, potatoes in, blah, blah, blah. Right, so that's the situation we've got. Now that isn't a mathematically very useful way of presenting it. It's hard to work with that very much. So let's imagine that these sacks are rectangles. They could be rectangular sacks. So let's imagine that. Thank you, Dr. Tabassum, for your congratulations on 10,000. Also to Abby and everybody else, Thanuja, Aaron. Yes, well, it's people like you who made this great moment in my life possible. 10,000 subscribers. I could never have dreamt of, of such prominence. Okay. So let's imagine that these sacks are rectangles, and let's do it like this. So we're going to have small sack and big sack. See my creative naming? So small sack is this rectangle and big sack is this rectangle. I'm not trying to draw to scale. Goodness me, that's the worst rectangle ever drawn. Sorry, in fact, I'm going to redraw it because it's so bad. It just hurts my eyes to look at that. That's a little bit more rectangular, sort of. Okay, you don't need to be accurate. Now, small sack and big sack together are 77 potatoes. Okay, 77 together. And small sack plus 20% is the same as big sack. So what we're doing is we're just taking the information from the question and representing it here. Now, if small sack plus 20% is big sack, let's have a look at the small sack again. So small sack plus 20%. So what does 20% mean? Now, I'm not going to do lots of maths here because I think we're in the realm of things that by the time you do the 11 plus, at least you should know, even if you don't know them now. So how many times does 20% go into a whole? Well, 20% is a fifth. That's one of those things you need to know. You need to know 20% is a fifth. You need to know that 50% is a half, that 10% is a tenth, and so on. So 20% is a fifth. And that means that 20%, we'll call that 1, goes into the small sack 5 times. Okay, so 5 of them and 1 of them are the same as the big sack, which means that the big sack is 6 of them. Are you following me? Let's recap that. The small sack, so we got, this is 20% on top here, okay? Follow my cursor on the end of my magic electro pen. 20% is 1/5 of a whole. So this whole small sack here must contain 5 of those things. And we can see from our picture that because the small sack plus 20% is the same as the big sack contains 6 of these units. Right. So we know that 5 of these units and 6 of these units together give 77. Let's call the units U. So we'll say that's 1 U. This is 5 U's and this is 6 U's. Okay. So 5 U plus 6 U gives 11 U's. And we know that all of those units together are equal to 77. So if 11 units are 77, then 1 U is 77 divided by 11, which is 7. So a unit is 7. Now we know the small sack is 5 units. Let's do an arrow. So 5 times 1 unit is 7. 5 times 7 is, you know this one, 35. And the big sack is 6 units. 6 times 7 is 42. Okay, so the small sack has 35 potatoes and the large sack has 42. Double check they add up to 77. Done it for you. Yes, they do. Okay. So it's kind of fiddly to get your mind around, but if you represent it clearly using a nice sort of bar diagram like this, it becomes relatively straightforward. And I think the key intellectual leap is recognizing that if the small sack and an extra 20% are the same as the big sack, then the small sack contains 5 units of some kind, and the big sack contains 6 of the same kind of units. Okay? So that is the situation as it stands at the moment. Now, I'm going to show you now another way using your best friend, algebra. I wanted to start with the non-algebraic method just to show you that you don't always have to default to algebra when doing these things. But these are tricky questions. Sometimes algebra is the easiest way, and I'm just going to clear this by reloading the document, which is nice and simple. There we are. Activate my pen, and we're away. Okay. So, yes, Diamond Panda, thank you. Everybody liked the video. And if you're finding it baffling, well, I suppose you can dislike it if you like, but I hope you won't. I hope you'll just go to the other videos on my channel about similar topics. A lot of them are easier than this. Go through the basics, get to understand this kind of question, and then come back to it. So I'm about to do some algebra. If this algebra is Chinese to you, then perhaps you're Chinese, in which case that means it's fantastically straightforward. But for the rest of you, if the algebra is Chinese to you, don't panic. Go to my basic Chinese, basic algebra lessons on the channel. Get used to those, and then come back to this, and you might understand better what I'm about to do. Okay, so what shall we call these sacks? Well, you can call them anything you want to, but let's call them, let's call the large sack L, okay? And the small sack, I'm not going to call it S because that looks like a 5 in my handwriting, so I'm just going to call it, what shall I call it? Come up with a letter. Someone give me a letter. T. T. There we are. T because someone is called No T, so it seems appropriate to call it T. Somebody in the comments called No T. I'm just defying them. Right. A large sack holds 20% more potatoes than a small sack. Okay? So 20% more is the whole, 100%, plus, you don't need to write this out, I'm just doing it to make it clear, plus 20%, which is 120%. And 120% is 1.2, because a whole is 1 and 20% is 0.2. Okay, converting percentages to decimals, it's something I've got videos about on the channel. You can look at those if this is confusing. Right, so 1.2 lots of the small sack, T, are the same as the amount in the large sack. So that's an equation. It shows that two things are equal. So the word equation. 1.2 of the small sack, T, are the same as the large sack. Right, now we also know that the two sacks, large sack and small sack, have 77 potatoes in them. So the amount of potatoes, number of potatoes in the large sack, the number of potatoes in the small sack together give 77. So this is another equation that we can work with here. Now, of course, we know that L is actually 1.2t. And this is the kind of step where I know some people will be confused, but I've got videos on this in my channel. Look at videos on algebra, look at videos on simultaneous equations, which is what we're doing here. But you don't need to know what it's called to kind of understand the concept. So what we're saying is that these things are the same. 1.2t is the same as L. And we got L here, we can write 1.2t instead because it's the same as it. 1.2t plus t. So we've taken this and we've just changed the L into 1.2t equals 77. What's t and 1.2t? Well, it's 2.2t. 2.2t's, so 1.2t's and 1t give 2.2t's are 77, okay? So, and this is where I'm not going to explain it in detail, look at my algebra videos if this doesn't make sense. We're going to divide both sides by 2.2. T is 77 divided by 2.2. Don't like decimals, going to times the top and the bottom by 10. Look at my videos on algebra, my videos on fractions if this doesn't make sense to you, just because this is easier to deal with. Okay, they're both even numbers, we can halve them, so 22 becomes 11. 770, well 700 divided by 2 is 350, 70 divided by 2 is 35. Add them together and we get 350 plus 35, 385, I very much hope. 385 divided by 11, well that's annoying, I think I should do a division. So 385 divided by 11. 11 goes into 38 3 times, 33. Got 5 left over. 11 goes into 55 5 times. So 35. So T is 35. Small sack T is 35. How do we find the large sack? We know that add up to 77. 77 minus 35 equals 42, which is the large sack. Okay, that's the algebra. Now, I know you may not understand this. It's okay. I've got videos on it. And it's the last time I'm going to say it for this question, but do not panic, especially if you're in year 4 or something and you're just starting your 11 plus journey. It's fine. Just look at this as kind of an example of the kind of thing you're aiming at when you understand 11 plus maths more fully. No one's expecting you to know this now. And in fact, doing this with algebra, it's not required because you can use the method that I showed before. Now, there is one final method you could use, which is trial and improvement. Guess a number of potatoes for the small sack. Times it by 1.2. Add the two together, see whether it's 77. If it's too small, increase the numbers. If it's too big, decrease the numbers and keep working until you get the answer. That approach also works. I'm not going to demonstrate it because you are probably as bored of this question as I am. On to the next one. Now, this question. This is, I think, basically an easier question than the last one. But I think that the people who set this question, because I've taken it from a real 11 plus paper, I think they made a mistake because it produces a really horrible answer that I would not expect at 11 plus. So I think there's something wrong with this. But there's, all we can do is solve it. Okay? And I thought I'd leave it in because, partly because I'm lazy and didn't want to change the worksheet, but also because I wanted to show you what to do if you get a question that may have a mistake in it and how you can just calmly power on through and get to the answer. It's not that the maths doesn't work, it's that the maths ends up being more complicated than it should at 11 plus. Now this question is largely here because it's inviting you to make a big mistake. Okay? So, it's inviting you to say, 30% plus 70% plus 80%. Add them together and get 180%. Well, if you can get 180%, which is a lot more than full marks in an 11 plus exam, then congratulations to you. But, it's not going to happen, is it? Okay? I'm just checking something in my head, actually, as I think about this. Something I want to think about. Anyway. No, let's not get sidetracked. There's more than one way that you could do this. But I think there's a very simple way to approach it, which makes sense. So you got 30% on a 10 problem test, 70% on a 20 problem test, and 80% on a 30 problem test. And then if they combine the test into one 60 problem test, what percentage is my score? So if you did the 3 tests and they said, we're just going to treat it as 3 parts of the same test. The easiest way to do this is to work out your mark in each test and then do that as a percentage of 60. Okay? There are other ways of doing it. That is definitely the most intellectually straightforward approach. And I, in my old age with my joddery intellect, I think that simple approaches have got a lot to recommend them. Grigri disagrees. He wants to make it complicated because he's young and enthusiastic, but we're going to ignore him. And he's, trying to get to sleep anyway, so who cares what he says. 30% on a 10 problem test. What would that be? So 30% of 10. I think we know the answer to this. 30% of 10, it's 3. 10% of 10 is 1. 30% is 3. If you don't know that, look at my videos on basic percentages. 70% on a 20 problem test. Well, I could get all mathematical about this, solving it with multiplications and such like. But let's just use our common sense. What would be what's 70% of 10? It's 7, right? So what's 70% of 20? It's twice as much. It's 14. 80% of 30. Well, at this point, you might start doing calculations, but we've started really well. Why not carry on with the same approach? It's going to work. What's 80% of 10? 8. 80% of 20? 16. 80% of 30? 24. Okay? So my total score across the 3 tests is 24 plus 14 plus 3. 24 plus 14 is 38 plus 3 is 41. So that's what I scored. I scored 41. We don't want to start circling, underlining too much along the way. It might look like we've chosen that as our final answer. 41, they're combined into one 60 problem test. So I got 41 out of the 60 marks. Now this is where I looked at the numbers I was getting, as I had a look at this earlier. I did actually look at these before the lesson, for once. So this is why I looked at my numbers and I thought, hang on a sec. I think they wanted something slightly different. I don't think 41 is what they were aiming for. But anyway, it's what we got. So I look at this and I think, how can I cancel this? And I look at it, and I look at it, and I look at it some more. 41 is not even. But also, it doesn't divide by 3. It doesn't divide by 6. It doesn't divide by 12. It's not dividing by anything convenient at all. So when you need to find a percentage, when you need to turn a fraction into a percentage, how do you do it? Drum roll on the mic. Okay. Abdullah says, Robert, once your writing used to bleed my eyes, now it's improved. That's just because I'm doing maths, and doing writing when you're doing maths is relatively easy. If I was writing a story or something, as I think I'll probably do next week, your eyes would be bleeding yet again. Anyway, 41 divided by... when you're converting a fraction into a percentage, so I got sidetracked, I shouldn't do that. I got told off once by someone who said, stop looking at the comments when you're doing a problem because you get distracted, and then so does my daughter. Sorry, whoever that was. I've done it again. Right. To convert a fraction to a percentage, it's really simple. You divide the top by the bottom and you times by 100. Okay? 41 divided by 60 is going to be fiddly to work out. I'd much rather divide by 6. What have I done there? I divided the top by 10 and the bottom by 10. So I've got rid of the naught from 60 by dividing by 10, but to keep the fraction with the same value, I have to divide the top as well. 41 divided by 10 is 4.1. I've taken the decimal point from there, and I've moved it left by 1 place to get 4.1. 4.1 divided by 6. Now, don't let the decimal scare you, it's just a normal division. 4.1 divided by 6. Now, you might say, what's the point of that? Well, let's find out what the point of it is. So 6 doesn't go into 4. So the decimal point carries up, 0 point. We've got 4 left over. So it's now 6 into 41. How many times does that go in? It goes 6 times, because 6 times 6 are 36. And we got 5 left over. What do we do with the 5 left over? Well, 4.1 is the same as 4.1, 0, 0, 0, and so on. That'll be enough zeros for our purposes, I hope. And by the way, this is the point where I think they made a mistake, because I don't think you'd be expected to do this very often at 11 plus, especially when you see what the answer is. Anyway, we got 5 left over. How many times does 6 go into 50? Well, 6 times 8 is 48. Okay, so it goes in 8 times. Remainder, I'm just checking my answer to make sure I've got the same thing. And 848, so it remainder 2. How many times 6 go into 20? It goes in 3 times. 3 times 6 is 18. We got remainder 2. How many times? It goes 3 times. We've got remainder 2. So it's going to be 3s forever. So it's going to be 0.6833333333. So we've done the division. We need to times by 100. So the decimal point is going to move from there to there, because times it by 100 moves the decimal point 2 places to the right. So it's going to be 68.3 going on forever %. And we show the going on forever with a dot above. That's recurring. 68.3 recurring %. Now, my friends, that is not an 11 plus answer. And you could legitimately think, if you were in the exam and you got the answer 68.3 recurring %, I've definitely made a mistake somewhere. Because the answer to an 11 plus question asking you to find a percentage, it's going to be a whole number %. In the very worst case, it might be 68.5%, one decimal place. The idea that you need to give the answer as a recurring decimal, no. The question, they've made a mistake in the question somewhere. They didn't mean this answer to come out. I looked at this, I thought, surely I've made a mistake. Don't think I have made a mistake. If I have, please tell me, but I don't think I have. Yeah, someone says, why was there a lesson last week? I had to whiz off and jump on an aeroplane to help somebody with something, which meant that I wasn't around. And that is why. Occasionally these things happen, but normally it's Tuesday evening at 6 o'clock as normal. Lovely to see so many people live in the lesson. I'm amazed you haven't gone away yet, as I've been bombarding you with these horrible questions, but well done for hanging around. You are superstars, all of you. Okay, stop asking me the same questions. Electric geography, I've already answered it. Right, onwards. So yes, that's horrible. Yes, there are other ways to solve it, but that's the simplest way to solve it, I'm pretty sure. Okay, this is actually a much easier question, but it does involve chewing through quite a lot of data. So going back to this question, there aren't so many words, but the working out takes a bit of thought. In this one, there are loads and loads and loads of words and numbers and letters, but the working out is ultimately fairly easy if you can navigate all the... Hang on, no, don't use a rude word, Robert. If you can navigate all this rubbish, okay? Table shows 4 different makes of car, each with 4 different engine sizes. Lovely. In litres and the insurance group for each. Don't you love insurance? The only thing more fun than insurance is tax. For example, a Hissan 1.5 car is in insurance group B. I love these car names. This is quite sort of Robert Lomax style question setting. Skoyota, Hissan, Vauxhall, Jagli. Can you guess what brands they're making fun of there? Anyway, I like it. So... and you can see we've got the insurance categories, we've got engine size. So for example, let's just have a look at random. If you had a car that had engine size 1.9 and it was a Jagli, it would be an insurance category D. Okay, so Jagli is obviously a car that people tend to crash expensively, so it costs you a lot of insurance. I wonder what brand that might be. Right, second table shows monthly insurance payment paid by drivers of different age bands for each of the insurance groups. So many words! Look, it's a table that shows how much you pay for your insurance. I fixed that for you. So, and they've given an example. So a person aged 37, so that's in this group here, would pay £105 each month for a car in insurance group C. So we go to insurance group C, we read across and we read down and we get to £105. If you're in an exam, I wouldn't recommend crossing all the numbers out like I've just done, but I have my magic pen and so I can do this. Ta-da! Oh, it's great to be me. Right, sucks to be you. Okay, on to the next. On to the questions. So there were an A and B somewhere, but they haven't turned up here. We're looking at C and D because we're advanced people like that. How much would a 50-year-old person save each month by using a 1.1 Hissan car rather than a 1.9 Hissan car? Okay, do not worry about how you get to the answer in the end. Just do the steps, okay? So a 1.1 Hissan, let's find that car. So Hissan 1.1, that's category A, okay? Hissan 1.1 is category A. Insurance group A, if you're 50, so you're over 45, that's going to be £70. Now a 1.9 Hissan, so we're in the Hissan column again, but 1.9 is here. So we go to here, that's insurance group C. We're still a 50-year-old, so someone who's pretty old but not quite as old as me. That's what we're talking about here. So we got £98 and £78. So how much would they save by using the cheaper one? Well, it's 98 minus 70. You guys are super smart. We don't need to do a subtraction here, in any formal way. You know that that's 28. So they're going to save £28. By the way, look, if there's any minuscule of a doubt, do the subtraction in a column. I just think this one's relatively easy. You can do 98 minus 70. It's just counting up 20 and then 8. Right. If a 32-year-old pays £95 for a Skoyota, that's my favourite of these car names, I think, £95 for a Skoyota car, what would a 20-year-old pay for a Jagli car with the same size engine? Right, okay, let's get rid of my circling so we can circle new things. Joys of my magic eraser. Right, 32-year-old pays £95, so we're just working through. If they paid £95, it's insurance group B. Okay, insurance group B and a Skoyota. So we got B Skoyota, that's here. So that's a 1.5 engine size. Okay. A Jagli car with the same engine size is category C. Category C is here. What would a 20-year-old pay? They'd pay 122. Okay. And that's the answer. A 20-year-old would pay £122. I'm not going to admit that when I did the working out before the lesson, I misread the question and got the wrong answer, because that would be very embarrassing. So I'm not going to tell you that. Okay, and onwards. Okay. This is at last a kind of question that I really like. I enjoy these questions. In fact, the rest of this is fun stuff, kind of puzzle questions. So let's have some coffee, contemplate the wonder of life and of mathematics, and then go on to the fun questions. Okay, because these are just kind of like puzzles. It didn't even feel like a maths exam. In Rainbow Land, there are lots of wuzzles. Okay, if you don't know what a wuzzle is, here's a wuzzle. Okay, this is a wuzzle. So wuzzles are all green, pink or blue. As you can see, this is a blue wuzzle. And they've got either big ears or small ears. I think he's got relatively small ears. So this is a small-eared blue wuzzle, just in case you were wondering. They like to live together in houses, which is nice. He also likes to live, in a house with other wuzzles and with humans. So, slightly different. He's a domesticated wuzzle. But then he doesn't live in Rainbow Land. He lives in, my flat land. In one wuzzle household, all the following statements are true. And we've got a lot of statements. And we need to find out how many kinds of wuzzle there are in each category. Right. Now, I have a magic trick for questions like this. I always set them out like this. We know that there are two categories, there are two criteria by which we define wuzzles. Okay? They are green, pink or blue. And they have big ears or small ears. And these cross over, because you could have a green that's got big ears, a green that's got small ears, a blue that's got small ears, a blue that's got big ears, and so on. And so I do it in a table, because that's how I roll. So, going to have colours along the top. Green, pink, and blue. Okay? And we can have big ears. I'm going to say big, not B, because I've got B for blue, and small ears. Okay? And I'm going to do the table like this. Notice this bit. I'm going on a bit beyond the B. There is a reason for that. There's a very important feature of these tables that may not be obvious to you, but will be when I've explained it. And I'm going to do the lines like this. Whoever said that my handwriting used to make their eyes bleed and now I'm so neat, I mean, this is a beautiful example of my newfound neatness. I am a reformed man. I am born again in tidiness. Okay. There's one more thing there. Right. Because these rows and columns are for the total, and that is going to be very useful. And now we start looking at the information. So we want to find a way in. There are more green Wuzzles than any other colour. Important to know, but that doesn't tell us any numbers. There are equal numbers of big-eared greens and small-eared greens. Okay, so these two are going to be equal. I'm just going to mark that with a little vertical equal sign. That's just a note for me. That's not a formal mathematical symbol. It's just a reminder for me. There are 3 Wuzzles with big ears. And this is where this total column is useful. Big ears is this row, so there are 3 of them. And now I've filled in my first number. And I can tick that because I've dealt with it. So as soon as I've finished with the line, I've done everything I can with it, I'll tick it. There are twice as many big-eared greens as big-eared pinks. So big-eared greens, that's here. Big-eared pinks, that's here. And this is where we need to start thinking. So could there be, for example, 6 big-eared greens and 3 big-eared pinks? No, because that's a total of 9 and the total's 3. There's only one way to fulfill this and not have more than 3. Twice as many, it must be 2 and 1. 2 big-eared greens, 1 big-eared pink, which is a total of 3, so therefore there are no big-eared blues. And suddenly, we've completed a row, just like that. And the way we did it was by having this totals column here and starting by filling in the 3, which is crucial. Alina says, I'm not even listening. Well, why are you here? Go away and do something more fun. What's the point of just... But you haven't heard me saying this because you're not listening. Okay. There are 3 times as many pink Wuzzles as blue Wuzzles. There are equal numbers of big-eared greens and small-eared greens. 2 and 2. Total 4. There are more green Wuzzles than any other colour. So the biggest that P can be is 3. Okay, it's less than or equal to 3. Biggest that B can be is 3. It's less than or equal to 3. That's a less than. This is a less than or equal to sign, by the way, just in case you were wondering. So what can we do with this? Well, let's have a look. Dealt with that. So we're just looking at this last row here. There are 3 times as many pink Wuzzles as blue Wuzzles. So it could be, for example, 12 and 4, but that wouldn't work because it can be the biggest that they can be are 3. So it must be 3 and 1 because that's the only way to have 3 times as many pink Wuzzles as blue Wuzzles. Oops, not 3 and 1 there, sorry. Oh yeah, that's right, 3 and 1. So therefore this is 2 and this is 1. These add up to 1, 2, 3, 4, 5. So let's just check that our totals in both columns add up. 3 and 5 is 8. 4, 3 and 1 is also 8. So that's our answer. Now, is it our final answer? I think if you gave me this table, I would just give it a big tick because it's clear what you're doing. But I think the sensible thing to do is to give them exactly what they want, unfortunately. So to write big-eared green. Here's my eye-bleeding handwriting. Big-eared green, 2. Big-eared pink, 1, and so on. I'm not going to do that now because you're going to get bored. You don't need to see it. You know how to do that. It's a bit of a waste of time. Now, important exam technique point. In the exam, it might also be a waste of time. You have clearly given your answer here. The examiner can see that. I think it should be okay. I would advise this. Finish the exam. Don't write the answers out in full like I'm doing here. But then when you've finished, if you have some spare time, come back and do it then, just to be absolutely certain. And that way you're protecting your time in the exam, but also if you have time, you're making absolutely sure not to lose anything here. Right. In another Wuzzle household, all of these statements are true. So we've got another one. So let's do the same thing. We know about Wuzzles. We know that they are, we know they're green, pink, blue. Pink and blue. We know they're big and small. And we know how to draw our table. Okay, so the totals, rows and columns on the outside, I use the double lines to separate them. I won't label them total because I'm lazy, as all of you already know. Right, what can we do with this? This one's going to be a bit trickier, isn't it? Because it's part B. There are the same number of pink Wuzzles as green Wuzzles. Okay, they're going to be the same. Totals are going to be the same. There are twice as many big-eared green Wuzzles as small-eared green Wuzzles. Okay, big, small. So that's something we'd come back to, I think. There are the same number of big-eared green Wuzzles as big-eared blue Wuzzles. All but one of the Wuzzles have big ears. Hang on, now we've got a number. What does this mean? All but one of the Wuzzles have big ears. That means that one of the Wuzzles has small ears. Only one. Total 1. Now we've got a number. What can we do with this? Where else is there a reference to small ears? Only in the second one here. There are twice as many big-eared green Wuzzles as small-eared green Wuzzles. Right. If it was... So we got one small-eared Wuzzle. If that Wuzzle is blue, that would mean there are no small-eared green Wuzzles. So what's twice of naught? It would be naught. Would you say there are twice as many big-eared green Wuzzles as small-eared green Wuzzles? Very naught and naught. No, you wouldn't. The one small Wuzzle must be green so that there can be twice as many big-eared ones. That must be the case, which means that there are no small-eared pink and no small-eared blue because there's only one in total. And now suddenly we are flying. There are the same number of big-eared green Wuzzles as big-eared blue Wuzzles. 2 and 2. Okay? Do the totals, by the way, because we got those. There are the same number of pink Wuzzles as green Wuzzles. So 3 pink Wuzzles in total, which means there must be 3 big-eared ones because there are no small-eared ones, and suddenly it's complete. And again, if you have time at the end of the exam, come and write out big-eared green Wuzzle, big-eared green 2, big-eared pink 3, big-eared blue 2, small-eared green 1, small-eared pink 0, small-eared blue 0. But don't waste time on it now because this here ought to be marked correct. Ought to be, but come back at the end of the exam if you've got time and make sure. Okay, and I was talking about puzzles. Here is a true puzzle question. And I thought this was a nice way to finish. This is a classic, the knight is telling a lie in front of the door question, but it's done slightly differently. On a game show, there are 3 doors. We can ignore the fact it's a game show. That's not relevant to anything. Behind one door, there is £1,000. And behind another, there is a spider. Behind the other door, there is nothing. Each door has a notice. However, only one notice is true. They put that in bold to be clear. So what are the notices? There's nothing behind door 3. So if this is true, there's nothing behind door 3. If it's false, there's something behind door 3. And so on. Behind which door is £1,000? Now, the sensible way to approach this is through trying things out. Now, with a question like this, you might think that the most important thing is being super smart, like Dimitri. But you'd be wrong. The most important thing is having a good system so that you don't lose track of your thoughts. Because even if your thoughts are nice and slow moving like mine, if you have a good clear system, it's fine if you move slowly because you won't need to keep checking back. So I suggest a system like this. We are going to start off by seeing whether only one notice is true. So let's just try each door. So let's imagine that door 1 is telling the truth. Okay, and put that under door 1. That means that door 2 must be false and door 3 must be false. So let's try this out. Door 1 says there's nothing behind door 3. If that's telling the truth, then there is nothing behind door 3. Okay? Door 2 is false. So if this says the spider is behind this door, the spider must be behind another door. The only possible door is this one. Spider. Okay? I could draw a little spider, but let's not waste time. Let's write spider. Okay? If door 3 is false, it says there's a spider behind door 1, it's false. So there isn't a spider behind door 1. But there is a spider behind door 1. We've already found that out. It doesn't work. It's contradicting itself. So this option with door 1 telling the truth cannot be right. Okay? Now let's try door 2 telling the truth. Okay? So we can get rid of this. Let's move on to the next option. Door 2 is telling the truth. So that means that door 1 is false and door 3 is false. Let's work through them. So if door 1 is false, there is nothing behind door 3. Well, that means there must be something behind door 3, but we don't know what. Door 2. The spider is behind this door. That's the truth. So spider. Door 3 is false. It says there's a spider behind door 1. So there isn't a spider behind door 1. That works. Because the spider is behind door 2. Okay, where's the £1,000? Door 1 says there's nothing behind door 3. That's false. So therefore, the nothing must be behind door 1 instead, which means that the £1,000 must be behind door 3. And door 3 doesn't contradict that. Door 3 said there's a spider behind door 1. In fact, there's nothing behind door 1. So this works, and we know the answer. There's £1,000 behind door 3. Now, let's just have a look at what happens if we make door 3 be true. Just to keep working through this. You can stop there. You found the answer. If you've worked carefully, that's the answer. It's fine. You can put down door 3. That's fine. I'm just doing this because it's an interesting question. It's the last question I've got here. Let's make the most of it. So let's imagine that door 3 is true. Okay, let's see whether this works. It's also a way of checking whether we made a mistake. Because, you know, if we get contradictory answers, then we're in a bit of a pickle. Okay, so door 1 is false. There's nothing behind door 3, so there must be something behind door 3. Either £1,000 or a spider. Door 2, the spider is behind this door. Okay, it's false, so the spider's behind one of the other doors. So we haven't actually got anywhere yet. Door 3, there's a spider behind door 1. That's true, so there's a spider behind door 1. Okay, right, let's work through again. The door 1 says there's nothing behind door 3. That's false, so there's something there. It can't be the spider because the spider's here, so it must be £1,000. Okay. Door 2, the spider's behind this door. Well, that's false. It isn't. And indeed, there's nothing behind that door because that's the thing that's left. So this also works. So it could be that door 2 is telling the truth. It could be that door 3 is telling the truth. Either works. It really doesn't matter because they both put the £1,000 in the same place. And all we're being asked to find out is behind which door is the £1,000. So you can imagine door 2 telling the truth or door 3 telling the truth. They give the same answer. You can't have door 1 telling the truth because it's a paradox. It's self-contradictory. Phew! We've got there. All right, people, let's push on to this week's splendiferous tip of the week. So Grigri is here, back compulsorily from his sleep. Oh, and he wants to get on my shoulder. He loves being on my shoulder because he can jump off on the other side. Right, the tip of the week this week is actually a bit of news. I'm running a extremely special offer with no catch attached, which is that you can send me a piece of your work completely for free, and I will give you individual feedback on it in little videos and comments. There are only 3 limitations on this. 4 limitations, but they're pretty simple. Number 1, if I get thousands of these things, if I just get more than I can cope with, obviously I can't do all of them, but I think that's unlikely. Number 2, it isn't for people who are platinum or super platinum members of 11 Plus Lifeline or who've sent me marking in the past. So it's only for people who've never sent me marking before, basically. You can send me a piece of work that is no more than 300 words. Okay, absolute maximum 300 words, because I'm going to get lots of these, and I'm not going to have time for it otherwise. So this is totally free. Send me a little story you've written, a little description, a little essay, and I will go through and I'll give my feedback with my trusty microphone and my trusty camera, and I'll tell you what's good and what you can improve and how to do it. and it'll be very, very exciting for you. If you want to find out more about this, I will post a link in the comments, but I'll tell you now, you can go to the RSL Educational website and put in the web address rsleducational.co.uk/free-marking. And there's a link to it on the 11 Plus Lifeline sign up page. So go to the 11 Plus Lifeline page. There's a big banner at the top which will take you to it. And this is an offer I'm running at the moment. The reason I'm running it is because I want to show people what my marking service is like, so that if they like it, they might sign up for a premium membership for 11 Plus Lifeline. But I'm offering it completely for free. I'm not going to make you sign up for anything. I'm not going to force you to pay me any money or anything like that. So it's a real opportunity to send me a piece of work for your own unique Robert Lomax and Grigri and possibly Dimitri feedback. Yeah, what could be more exciting? I'll post a link and some information in a comment under this video as soon as I've done. Basically. All right, enough of that. Let's get on to yes, it's your questions. Wubix Lube, who is a very impatient chap, says, when my pen coming, I need it. You do need it because you need to practice your English, evidently. No, joking apart, I did say in my email back to you, I said, or back to your mother, I think, I said, it will be posted at the end of this week. Young Mr. Lube, is this the end of the week? It is not. It is Tuesday. That is why your pen has not been posted yet. And the reason is because my father-in-law, who posts out these things, is currently having a nice holiday, which I think he's very much earned. So that's why he's not posting the pens at the moment. Deal with it. Kartik Dange says, so like danger. I've nearly completed my first live lesson. Wonderful to have you. Welcome to the channel. Alina says, I want Dimitri, please. Where is Dimitri? Maybe you can have Dimitri. Where's Dimitri? I mean, you can't have him. He's mine. But can he join us? Just give me a second. I'll just have a quick look. Oh, poor boy, he's asleep. Not for much longer. There you are. Here is Mr. Dimitri. Dimitri, a very special week for Dimitri because he this week he passed his 6 kilogram weight day. In other words, he reached 6 kilos for the first time. I mean, Siberians can get up to sometimes 11 or 12 kilos. So they get enormous, but he's already a pretty big boy. And very excitingly, on the 26th, it's Dimitri's first birthday. He's going to be 1 this week. The excitement, I hope you'll all be sending him your presents. Anyway, God, he looks very excited to see you, doesn't he? Right, let's look at some of the other questions. The creator, Robert, I got into Christ Hospital and will go in September. Thank you so much for your help, Robert. In block capitals, that's the level of excitement. Dimitri says he hates block capitals. Look at him rolling his head away. Many congratulations. I hope you have a wonderful time there. It's a long time since I was there, either as a pupil or as a teacher, but it's a fantastic place. So you have a wonderful time. Krishna, what is the best routine for girls Kent Des 11 Plus? I don't think girls require a particular routine. People always ask me about routine and study routine. And what I always say is something very unhelpful. I say something along the lines of, you are now at an age where you can kind of own your own learning and find a routine that works for you. So play with things. Think on this. Do you see that bit of fluff drift down? It actually showed on the camera. Anyway, He's just a big floof, and the fluff goes everywhere. You need to try things out. You need to find routines that work. So try certain amounts of study, try how often you study, whether you study in bigger blocks, shorter blocks, what you do for breaks. And this is your chance to experiment, to find a routine that really works for you. What works for somebody else is not going to be quite what works for you. Abby says, Robert, are you from Switzerland? I'm not from Switzerland, but I do live in Switzerland. So you're kind of on the way there. Abdullah says, is Colleton Grammar School a good school? I'm sure it is, but I don't actually know to say. Janani is asking a chain question. How to practice more fast maths? By that I mean how to practice efficient maths. Good question. Watch my maths videos and look at some of the methods and find the ones that work. I think it's about more than one thing. There's no easy answer to this, and I'm not going to talk about it for hours. But for one thing, working more quickly is often actually about identifying the things that slow you down and learning to solve those problems so that they don't slow you down in the future. One way that people waste time in maths exams is that they look at a question and think, I don't know what to do, and they stare at it for ages. The best thing you can do is start jotting down the information in the question. So for example, let's pull up an example from today's lesson. So when we were looking at not the Scoia'ta, much as I like it, and when we were looking, this question up here, that was the old version. So the original version, I started off by just sketching the sacks, didn't I? And then I thought these were a bit not very useful, so then I turned them into rectangles. And then I dotted the difference and I started labeling the rectangles. So I just started by putting down the information. From the question in a simple form, and that led me into it. So one way that people work inefficiently is by staring at the question and not just putting down what they know, because they're so obsessed with the answer, they don't just do the steps. So just do the steps. That's another thing. Lastly, I would say it's about finding methods that really work for you. In fact, let's go back into the lesson. So for instance, very good example here. I saw this question about the Wuzzles and I recognized it as the question where you can do a table and fill in the spaces, and that's the easiest technique for it. And so once I knew that, it was quite efficient and it was quite quick to solve, even though it's set up as quite a long question in an exam. So I could actually claw back some minutes by doing that more quickly than the examiner expects. So that's another kind of efficiency, having some methods up my sleeve that I know how to use and I know when to apply them. So there are lots of different things. Karen says, please respond to mine. So I'm getting squizillions of questions here, so it's hard. There's some... Mr. Hay, you're going to get banned, I think. And then if you come back to me, I'm doing after the lesson, and if you come back to me with appropriate contrition, then maybe I'll unban you in the future. Can't have that kind of language in the chat. No, it just spoils it for everybody. If people keep just swearing in the chat, I'll just have to not have the live chat, and that's going to ruin it. Sanarum likes my creative writing videos. Thank you. Tanuja says, can I do more Kent test papers? If they release more practice material, then I can have a look at it. But, depends on that. Someone's very sad I wasn't there last week. I think people are running out of questions. Someone says, how do you do mental maths faster? Practice, and as you practice, you'll learn certain shortcuts, basically. You can also look up shortcuts for mental maths and learn them, but it's largely about practice and getting used to methods that work well in your head. Where are you from? I'm from all over the north of England, basically. I was born in the northwest. I grew up in the northeast, and I was back in the northwest. I mostly grew up on the kind of border, halfway between Newcastle and Edinburgh, basically. I don't sound like it. Rubik's Lube, do not be rude, please. Are you from London? I'm not. I'd lived in London for 10 years, but I'm not from London. In the end, I managed to get out. I'm not a big fan of London, to be honest. Wonderful people who live there. Everybody is in London, but I just don't like being in a huge city. Tips for time management. See above the things I said for math. I think that's enough for today. Someone says they got into City because of you. Also, have thank you so much. Thank you so much for saying it. You got in because of you, but I'm delighted that I could help. Right, the questions are running. Running away from us. What am I saying? We're running out of good questions. So let's build towards calling it a day. It's been... Oh, I didn't have my logo before. There we are. I'll have to reactivate that. Let's just do that now. You can be with me in this momentous moment while I reactivate the logo. There we are. Fantastic. Okay. Right, play out music. It's been fantastic to have you here. It's been wonderful to have a lesson. Dimitri's still here, so he's going to come to say, yes, there is no escape, Dimitri. Dimitri's here to say goodbye. Fantastic to have you. Have a look at my free marking offer. Send me your work. I'll be delighted to have a look, as long as thousands of you don't. And send you back my feedback in voice and video comments. And I'll post a link in the comments almost as soon as I've finished. So check back at the video and have a look at that. In the real comments, not the live ones. Real? Permanent comments. All right, Dimitri is delighted to be here. He's very proud to be turning 1 this week. So all of you wish him a happy birthday. And I will see you back next Tuesday at 6 o'clock, probably for some writing, I think. Dimitri's good at writing. He'll help with that. All right, big head. All right. Let's say goodbye to everybody. It's madness in this household.